Hi friends, I am Uday Sagar Kandpal and I welcome you all to yet another lecture on Java using Netbeans IDE. So the topic for today is nth root of a number. So in previous lectures I have discussed about the square root of a number. Now today we will discuss about nth root of a number. So for that we will use the Newton-Raphson method. So before we start, I would like to ask all my new viewers to please subscribe to my channel and please like my video on YouTube and comment and share, and also press the bell icon for notifications. Thank you. So let's begin. So let's name it as nth. So let's finish. Now I will write the Newton-Raphsonian method or function before you. So I have written the formula for the Newton-Raphson method. Xk plus 1 equal to xk minus f of x divided by f of dash x, that f of dash x is the differential and fx is the function. So I have noted here f of x is equal to x to the power n minus s, where s is the root. So f of dash x is equal to n into x to the power n minus 1. X of k plus 1 equal to x of k minus x of k to the power n minus s divided by n into x to the power xk to the power n minus 1. So we have simplified it to x of k plus 1 equal to 1 by n into x of k into n minus 1 plus s divided by x to the power k into to the power n minus 1. So I have simplified it and created the Newton-Raphson function. So let's write the Newton-Raphson function. So I have already created the Newton-Raphson function. So I have passed double n, double s. I can rename this function as nth root, and the nth root function is created. So let's now test it. So let's create the public static void main. Let's print nth root, say 3, the third root of 27. Now let's print out. So it's printing 3.0. The third root of 27 is 3.0. Let's create the nth root of 64. Let's find the nth root of 64. So it is 4. It is giving the correct answer. Let's do it for 8. It's 2.0. Again the correct answer. So we have already created the nth root of a number by a simple formula which is known as the Newton-Raphson's method, where we have created the iterations. And when will the iteration stop? When the previous iteration is equal to the current iteration value. When there is negligible difference between the iterations, it will automatically stop. Here we have used the math.pow function to calculate the n minus 1th power. Power function can be done in log n time using binary method. So this is how we have done the nth root. You can take a look at a simple code. We have defined a double xk. Initial guess is 1. We have defined a previous x equal to 0. We have created a while loop for previous x not equal to xk. Previous x is equal to xk and xk is equal to 1 by n into xk into n minus 1 plus s divided by math.pow xk n minus 1. So it's a simple method to calculate the nth root. It will give the nth root of any number that's possible. 125. Let's run for 125. 5. Let's run for 125.987. 5.01. So it will work for both decimal and integer. So hope you liked my video. Thanks for watching. Bye bye.